So I'm going to start by starting high level. So some ideas and how to use the new event-driven versus what we have today, which is a lot REST request response. So I want to start by comparing what is the new thing that is going to solve all my problems versus reality. Then we implement this and it actually doesn't work. So how can we prepare ourselves going more than just what the new thing is? So like I was saying, I'm going to start with the high level. I'm going to do a demo, and then I'm going to do a deep dive into Kinesis and how actually Kinesis works. So with that in mind, let's refresh what we have today. So we have the request response model, which is basically a synchronization app where when the customer comes in and make a request, we need to have something in the other side to respond. This is a huge requirement, which means that if you have one customer, easy, one server. But if you have 1,000 customers, then how are you gonna scale? How much time do you have to scale? So it's a huge requirement. So what is the counterpart of this? Do you guys have any idea? What else is there? So asynchronous event, yay! So asynchronous event works in this case where something happened, then you go away. Somewhere in the future, something is you are going to receive another event telling you what to do. So it's this idea of don't call us, we'll call you when it's ready. So with this in mind, I started working with asynchronous event on this particular use case where I had to reschedule my flight. So I called the airline. I had to wait in line for a lot of time, and suddenly you receive the wait. No.
Please stay in line.
It works. So you get prompted with your call is very important to us. Please hold. Like, how important am I if I'm being here like half an hour? Not much, right? So a couple of guys actually implemented a feature where you don't wait in line, but just we'll call you back when an agent is ready. So it was beautiful. You call, okay, I need to do this and that, and then you hang up. You do other stuff, then they'll call you back in 1 hour, 2 hours, whatever. We don't care, but the customer is not online. We don't hold the resources, and everybody wins. Win-win. So how can we implement something like this in our services? So I have background on the IVR on telephone, so I'm gonna pick the IVR use case.
Hi, Alonzo. This is pay by phone parking system. How can I help?
So this would be a prompt, and as you can see, the system recognized myself. So Alonso, right? So, but in the asynchronous model, you send a message, and sometime in the future, you will receive that message back. So what do? You wait. And what other options do we have? Maybe you send another message. And then what? You keep waiting. At some point, you will need to give the bad news, right? So you need to go back to your customer, and what are you going to tell them? What do you suggest in this particular case? Any volunteers?
In progress.
So
in progress.
Fail or in progress, but okay, the customer is in line. You need to move the conversation forward, right? So is this theory of fail forward? So we are not going to fail. We're going to pretend we are working. So we can phrase this scenario as.
This is pay by phone parking system. How can I help?
So at this point, we don't know who you are, but we don't know what you want either. So maybe he can be treated as guest. We don't know. Let's fail forward and move the conversation forward. So in this particular case, I'm going to say, I want to pay for parking. Okay.
Let's create a parking session for you. Could you start by telling me the location number?
So here I'm going to say like 4969.
4965. Let me take a look. Is that the one in front of Save on Foods?
So see, great. This is a confirmation. So personalizations. But again, what happened is the system is down, there is latency or whatever. How will we fail forward in this particular case? Any volunteers?
Just pretend we paid.
Come in.
Just pretend that everything's down on the page and we did it.
See, possibly. So what we could do in this case is actually answer with another question. Let's use the customer to confirm.
4965. Let me take a look. Are you sure the location is 4965?
So one thing to keep in mind here is that if the customer is a normal customer and they call several times and they get this different prompt, it's gonna be worried of why. So maybe I did a mistake and the system doesn't recognize that number. He doesn't know if it's a feature or the system is down, right? So, okay, so let's move the conversation forward.
For how long would you like to park?
And just for an hour.
Parking session on 4965 for 1 hour would cost $3.50.
So
Okay.
this is a big one. In this case, would you still pretend the system is off or move the conversation forward?
Okay, we actually don't know the number.
Yeah,
We don't know how
basically
much.
say that the tree being great or the tree being cost or something like that.
So are you telling me that if we go to our clients and we tell them the system is down, you don't want to at least receive the event that they want to park? So this is a comparison. The system is down. Is it better to say, hold on, the system is down, don't give me money, or don't worry, give me what you want, we'll get to you later. So then we can phrase this as differently. So imagine that now your channels are not page by phone channels, but they are actually being the customer. They are impersonating the customer. In this case, you can say something like,
About to create a parking session on 4965 for 1 hour. Is that okay?
so in this case, the channel is actually representing the customer talking to pay by phone, right? So this is still okay. So one thing to keep in mind about this interaction is these two parameters. This is what the whole interaction is about. I want to know that you want to pay for parking in this location for this long. No matter what happened on the system, we want to capture those parameters. So in that case, we are in control. The system is down. If they don't have, for example, the identity thing is down, we didn't confirm their identity. We don't know if they have a credit card, but we know that they want to park in this particular case. So we can call them back or send an email, an SMS, whatever, but we have the data to actually follow up. It's not like the system is down, we didn't even know what happened. So with this in mind, let's start with our first demo. So how this whole thing is going to work, this is what I'm going to show. So keep in mind that this is going to go in the same interaction, like it's going to confirm the identity, it's going to check the personalization, and then it's going to get the quotes. But I have a 25% chance that it's going to be an error. So you're going to have a slightly different prompt and move the conversation forward. After the fact, there is going to be another process outside of this interaction that is actually going to reconcile the whole interaction and confirm that everything is good.
This is pay by phone parking system. How can I help? For what for? Pay for parking, pay for ticket, update your account, or customer service? Let's create a new parking session for you. Could you start by typing the location number? $4545. Let me take a look. Is that the one in front of Save on Foods? From 1 to 2? Yes or no? And for how long would you like to park? From 1 to 3 minutes, hours, or days? How many minutes? A parking session on 4545 for 45 minutes would cost $3.50. Is that okay? From 1 to 2? Yes or no? Awesome.
So
You are all set. The current session is going to expire today at 6:45. Have a good.
So in this particular case, our identity failed. And then once I submitted the record event, it's going to be saved into Dynamo Kinesis. And then something in the future is actually going to reconcile and check that everything is fine. So what is actually behind this? Oh. So first, the customer call. Then what is going to take care of the telecom is Amazon Connect, which is a call center on the cloud on Amazon. And from this is going to call a Lambda function. The Lambda function then is going to call our services, identity, personalization, and quote. And sometime in the future, when we have those three parameters, we want to save that in a persistent way. So we use Kinesis. So then in Kinesis, we have a consumer that is actually going to one by one go and reconcile. So another part of this is that I'm using IoT. So we can have a bus of events that can listen to all these interactions. So we can have the dashboard. So now that we have this whole interaction, I'm going to go a little bit deeper into how Kinesis works. So let's start by Kinesis is basically an array with temporally records. So that means that the head is right now, and the tail is something in the past. So in this case, this is called expiration time. It could be 24 hours up to a week, I think. So what happens is that you add a new record. It's going to be there, so anybody can actually go and get that record until expires. Once it expires, it's deleted. You cannot get that record again. So let's see that we have all these data in that Kinesis. How can we actually use that data? So you have consumers. Consumers are basically an application that is going to have a cursor. Cursor is basically where in the stream I'm located. So it's going to go from the past up to now, one by one or by bash. So one by one until it's now. So in this particular case, as you could see on the example, the response was actually quite fast because there are no records there. So the consumer is ready to process as it goes. But what happens if we get a peak hour and we get 1,000 events? The consumer won't be able to catch up. So then the cursor is actually going to start moving to the left until the peak hour goes down, and it's going to catch up until now again in the future. So this gives a lot of elasticity. So there is a huge problem or constraint with Kinesis, I should say, that it takes a lot of care about ordering. So to the extreme that if you receive an event that it doesn't know how to handle, so it throws, the whole pipe is going to stop until that event expires. So let me rephrase that. What happens is that if you receive an event that the consumer doesn't know how to handle, is going to wait, in this case, 7 hours until that record expires, and then the pipe move on. So how can you handle this? It's impossible. I don't want to stop, but go for it.
One cursor or all cursors?
That's my next thing. So you're gonna only have one cursor. You can have multiple cursors. So each application is going to handle their own failover. Maybe one application don't care if it doesn't recognize. It just moves forward. But another application might care and it rather wait the 7 hours. So that 7 hours might be a span of time that we as developer can go and fix stuff. Right? So you can actually spend a week just fixing that specific event. You have a metric to see, oh, I didn't catch that. So you can go fix it, and then eventually it's going to fail. So now the next question is, yeah, this sounds great, but how does it scale, right? So it's impossible that one little array is going to handle millions and millions of events, right? No, it's not possible. However, so we have two problems here. One is the consumer. The consumer needs to catch up. So you can only process many events per second. And Kinesis itself can handle so many events per second. To be exact, is 1,000 requests per second, 1,000 records per second. So then how can you handle this? So literally you have a number that you are going to set how many of these arrays you want. So then you say, I want 3. Okay, it takes seconds to change from 1 to 3. So now, how are we going to actually split all these events into these 3 different arrays? So it's called partition key. So you can set your partition key by customers, by city, by vendor. Depends on each use case. So then what happens is that now Kinesis knows, oh, I can solve this problem. I can actually put all the blues in one, on the reds in one, and all the blacks in one. So that's taken care by you. You don't need to worry about that. So on the other part is that, okay, but now I need, how do I know how many consumers? Is it 2? What is that? So in this example, I use Lambda. So on Lambda, it grows and shrinks automatically. So on this example, these 3 lambdas are not actually 3 different lambdas. They are 1 lambda and 3 instances. So you can actually manage 1 code base. So going back, I think you can treat Kinesis as one big chunk of events that Lambda is going to handle automatically. I think I went really fast. I thought I was going to spend more time. Any questions?